Hello, this is Dr. Hucks here. This video is going to show us how to do a standard score and percentile rank for a distribution of class scores. Here we have Jim's algebra class, and here's the distribution of scores for the final exam. And we want to find the standard scores and the percentile ranks. What we're going to do is use Excel to apply the standardized function and the percent rank function for f of x to standardize these scores into z-scores and find their percentile ranks. Now, the first thing we're going to need to do is put this table in a spreadsheet. So go up here, copy that table, go over here to cell A1, brighten it, and then paste that table in there. And let's go ahead and take this out. I'm not sure what that was about, but we don't need it. And here we have all we do need. Count. This could be names. It could be any student ID or anything. Jim's class raw scores in column 1. The standard scores we're going to find and place in here, and the percentile ranks here. We also need a place for our mean and standard deviation. So let's take this little table right here with us and copy it and put it back in, and we'll just place it right here. So now we have everything we need. We want to find the mean and the standard deviation for this. The mean is in Excel is called the average. You can go to function, and then you can put in the word average, and then just go hit the function button, and it gives you a display to put the numbers in that you want. So what you do is make sure your cursor is in there, go over here and put the array of numbers in there, B4 through B12, and push OK. And there we have the mean. The average for this group of numbers is 77.222222. And I don't think we need any more than that. That'll work the same way. We can do the standard deviation the same way. Let's go over to, but there's another way to do this. We can type an equal sign in there, and then we can start out with STD, and it will pop up, and we have to select one of these. And we're going to use the standard deviation of a population as opposed to using a sample. So population sample, and the reason we're doing that is because we're going to be working with the normal curve, and that's about the z-scores and that sort of thing. So here we want the standard deviation, and since I moved my cursor around, I'm going to have to redo that. Now let's just put equal STD P and double click that, and it wants the array of numbers for that. So I'm going to go over here and get that same array, and then I'm not even going to close parentheses. It'll give me the value without doing that. How nice. Let's see. So let's reduce the number of, let's maybe go down to 2. So now we have the standard deviation and the mean. Over here, we want to put the standard scores. We want to convert all these scores to z-scores. So we'll do that with the same thing we're going to do. We're going to pick right here the standardize function. And you'll see the standardize function comes up. It wants to know what score we're going to standardize. It's this score. And the mean, where's the mean? Okay, the mean is over here. Where's the standard deviation? It is over here. And push OK. And here we have the standard score, the z-score for 71. It looks like it's to the left in the normal curve of the average. It's a half a unit to the left. Now, we would normally fill in the rest of these by just pulling this down. But notice I get an error. I get this thing right here. The reason is I need to lock J2 and K2 in where these others are. So I'll just highlight that. Hit F4, you notice the dollar signs come about. Highlight that, hit F4, and the dollar signs come about. And these values are locked to these values. When I change B4 to B5, these will not change. So let's see what happens here. Let's try that. notice that B4 changed to B5, but these others did not change. So we'll just drag that all the way down and we'll have that taken care of. So now we have the Z-scores for all of these scores. Now let's do the percentile ranks very similarly. Let's go to function and do, you could type in percentile rank, but I'm going to use percentile rank included because that's going to include the scores themselves, the 0 and 100% level. And it again wants the array of numbers. There's the array of numbers. And then it wants to know what value we're going to put in there. And we're going to put in this number. We want this array of numbers. And then here for X, we want the number 71. And then we're going to push OK. And if we change that to a percent and maybe give it a decimal point or two, it's in the 25th percentile of this distribution. The scores, it scored at the 25th percentile. Now, again, if we start to drag this down, it's not going to give us the correct values because when we drag that down, we change these. We change some other values as well. So let's do this. Let's go back to this and let's lock in the distribution. That's this score over here, these scores over here. So the B4, I'm going to hit F4. And for B12, I'm going to hit F4 on the keyboard. And that'll lock that in. And when I drag this down, I'll have the percentile rankings for all these scores. It looks like this one's at the 100th percentile. That must be the top score. 100% of the scores are at or below this score. And this score 85, 75% of the scores are at or below this value of 75%. Now we want to fill the rest of this table out. The highest value, well, we can just look at this score and find the highest value, and we can just type that in. It's 98. There's another way to get to these scores too. If I want to know the median, the middle score for this, I can go over here and type equal, MED, and the median function will come up. And what I need to do is just put this array in there, hit equals, and the median score is 75. It's the middle score. And that sounds about right. The average was 77, so the middle score ought to be somewhere. The lowest score, another way to do that is put equal, MIN, and the minimum score will be found in that distribution. All I have to do is type that in and do this. You can find these by actually looking at our table we made. But here we have the scores, 98, the highest, the median, the lowest. Now let's put the Z-scores in here. What's the highest Z-score? Well, the highest Z-score is, why don't we use the max function? Let's just go equal max, double click, do this, and there's the highest Z-score. I'm going to say it's going to match up with that one right there. What's the median Z-score? We can do that again. Equal MED, median. That'll give us the median Z-score. The lowest Z-score is going to be, well, we know what it's going to be, but I'm going to just do this. It's going to be 0, I'm sure. Minimum. And let's do this. And I'm sorry, it's going to be -1. We're doing Z-scores. I was thinking something else. What's the average for a Z-score? Now, what do you think the average of the Z-scores are going to be? Let's just see. A equal AB, G, AVERAGE. So let's do average, and let's go with the Z-scores, and let's see where we are. And that is so small, I think you could call that 0. As a matter of fact, if I go up here to data and page layout home and make that a number, you're going to get 0. So you would think the average should be in the middle. That should be 0 as far as Z-scores are concerned. What is this going to be? The standard deviation. What do you think the standard deviation is for ST, oh wait, I can push equals ST standard. I'm not wanting to standardize. I want to find the standard deviation. So I'm going to do this. And go to that. And here it is, standard deviation of a population. And let's see, what are we doing now? We're doing the z-scores. So let's do the standard deviation of that array. And it's 1. A normal curve, a normal distribution, has a standard deviation of 1 standard deviation, and z-scores anyway, and a average score is in the middle is 0. Now you can do the same thing for percentiles. You can go through these percentiles and do the same thing. I'll leave that with you, and hope you enjoy the exercise you're going to be assigned. Thank you.